Hi students, I want to talk about assignment 4 and give you an opportunity to resubmit that assignment drawing. Okay, so in assignment number 4, what we have is a part I'm asking you to modify. Here is the part. It is a guide bar. It's a very simple part. It's got, length, width, and height, and it's got 3 holes in it. In which case there's, just a very simple set of dimensions here. Then we have a note telling what material to make it out of. This M2 is a tool steel, and the HTTS is heat treated tool steel, RC4060. So this tells the manufacturer who's making the part what to make the part out of and what to heat treat the part to. Then the other note I have on here is a standard tolerance. All parts have a tolerance. If you're going to go out and manufacture this part, it has to have tolerances on all features, or else the drawing is not complete. Okay, so this is kind of the gist of this class. Is we're going to make these drawings here, and then they're feasible for manufacturing. So yeah, we have a very simple drawing, but everything is defined on here: the material, the heat treat, the tolerances, all the dimensions are defined and properly represented on the drawing, and each dimension has a tolerance. Here, the bilateral tolerance is explicitly stated on the part because it's a little tighter than the rest of the parts, the rest of the features on the part. But we do have a standard tolerance, so when I don't have a tolerance listed here, I default to this. So I'm showing this drawing feature here to 3 decimal places, so therefore tolerance is plus or minus 5. So this is the gist of what we're trying to do, and what we're going to do is modify this. We're going to make the leftmost hole a countersink hole, and I've given you some requirements on that. We're going to make the rightmost hole a counterbore hole to accept a certain cap, screw, and washer, and then we're going to add some chamfers to the lower surfaces of the part, lower edges of the part, and then that lower surface needs a surface finish. So these were the things that we learned in this lesson 4: how to dimension features and how to add surface finish callouts. So how do we go about doing that? And then some of the other things I wanted here is I wanted some sizes. I wanted you to do a little design work. Okay, so for this one, I'm giving you a screw that the countersunk hole must accept. Okay, so the screw head has a 411 thousandths diameter, and so what we have to do is design our countersink such that that countersink feature is big enough such that the screw head sits below flush. Now, to dimension a countersink, what we're going to do is we give a through hole size, and we give a diameter of the countersink at the breakout at the top, and then we also give an angle for that countersink. Okay, so what we need to know is when we're designing our new part that our countersink has to be bigger than this 411 thousandths. Now, when I say bigger than 411 thousandths, that has to include your tolerance as well. So if you had the breakout diameter of 411 thousandths and your tolerance is plus or minus 5, that's not good enough, because what you really need is the minimum dimension has to be 411 thousandths. So if you had a tolerance of plus or minus 5, then your dimension would be 416 thousandths plus or minus 5. Okay, so you need to size that countersink hole to fit this screw, 82 degrees and a diameter bigger than 411 thousandths in all tolerance conditions. Now, next is the rightmost hole has to have a counter bore. And what I want you to do is design that counter bore and depth to accept what I'm saying here. And that is a washer. You need to drop a washer down to the bottom of that counter bore, and then you need to set a screw on top of that washer. Now, the head of the screw cannot sit above flush that upper surface of the guide bar part. You need that head to sit below flush. Okay, so to do that, what we have to do is to calculate what the maximum height of that screw head's going to be, along with the thickness of the washer. And that's why I gave you these drawings here. First of all, let's look at the washer. I'm going to tell you right now that the washer outside diameter is bigger than the screw head outside diameter. Therefore, when you're sizing your counterbore diameter, you have to go bigger than this washer. I specified the washer as a C10L, NAS 620 C10L. So here's the NAS 620 specification. Here's the 10L, and it's 32 thousandths thick. So you can assume that the tolerance on that thickness is plus or minus 5. So therefore, our maximum washer thickness is going to be 37 thousandths. Now let's look at the screw head. Here's the screw head drawing. So again, here is a NAS 1351. It's a standard part definition for a National Aerospace Standard screw. And I said we're going to use a 1032, which is a -3. And the dimensions for a -3 screw are right in here, and this line right in here. First of all, we want to get to the head height, which is dimension H for 1032. H is 190 maximum. Okay, so what you need to do is you need to add 190 thousandths to your 37 thousandths, and I get a maximum depth, a minimum depth of 227 thousandths. Okay, so what you need to do is, like, okay, again, if you put a tolerance on that of plus or minus 5, you have to have your maximum depth go to 232 thousandths. You know, you have to have considering all the tolerances, that head has to be below flush. Okay. Now the other piece of design work I asked you to do was to size the through holes on both of those modified holes to clear the fastener diameter by 20 thousandths minimum. Okay. Now to do that, we need to know what the maximum diameter of the body of the screw is. So the maximum diameter of the body of the screw, this is called out as a unified thread. Okay, it's called out as a number 1032 or a 19032, like it says right here. Okay, so what you can readily see by this chart is that our unified thread standards are called out here. This is the basic size of the screw. This is the threads per inch. Every size of thread listed on this screen right here is a UNF, a fine thread. Okay, so this is a UNF thread specification, and really what this says is that for this nominal size of our thread is actually the maximum diameter of the body of the shank of the thread. So essentially the nominal diameter in a UNF thread designation, the nominal diameter is the maximum diameter of the shank of the screw. It's like the maximum outside diameter of the threads of that part. Okay, so what that says is 190 thousandths is our maximum diameter of the shank body for both of these holes, and you have to clear it by 20 thousandths, like it says in the problem statement, which is 190 plus 20 thousandths is 210 thousandths. And then if you wanted a plus or minus 5 thousandths tolerance, you would have to add that to it. So it would be a 215 thousandths plus or minus 5. So those were the simple calculations I asked you to do when defining these holes. The other thing I need to consider is that, this drawing is going to be used for quoting and manufacturing purposes, which means you need to make sure that all the dimensions are properly shown on the drawing and all tolerances are assigned to each feature. Um, and also use some drawing notes placed in the lower left hand corner. The material hardness and the material and hardness will be the same as specified in the guide bar drawing. What that means is that you have to give me this, you have to give me these standard tolerances for the parts, and you have to give me this material note. Yeah, so this is what we're striving to do in this class, is create these proper drawings. So what I'm going to do is I'm going to allow you to resubmit this drawing. Make sure you get the notes on it, make sure you covered everything in the problem assignment, and then make sure that your left hole and your rightmost hole are dimensioned properly per the stuff I just told you about. So thank you. I'm going to open it back up, and you can resubmit your drawing only. Thank you.